Next, I am glad to welcome Aravind Raju, the VP of Applied AI at Unifor. Over the past 2 decades, he has been fortunate to build and experience the evolution and adoption of AI, specifically speech and NLP. He has led teams in developing cutting-edge AI solutions to drive consumer and enterprise deployments. Aravind strongly believes data is the key to AI success, not an algorithm. According to Aravind, for commercial AI takes algorithm, UX, software engineering, and most importantly, people toiling hard to make seemingly successful research work in the real world. More recently, he has a newfound appreciation for tooling that help customer self-serve work deployments. And finally, he insists that there is no successful AI product that does not employ the trifecta of MLOps, DataOps, and DevOps. Today, he will share his best experience with challenges in applied conversational AI. Aravind, the mic is yours.
Thanks, Joel, for the introduction. And thanks for the opportunity to share my learnings and experience in conversational AI. I'm the VP of Applied AI at Unifor, and today I'll be talking about applied conversational AI and its challenges. As Joel said in his introduction about me, one of the things that I've appreciated over the years is the learning that it's not all about algorithms and machine learning that makes or breaks AI systems. Here on this slide, you'll see that this is copied from one of the seminal papers by Google. This was published way back in 2015. And what they had talked about was the hidden technical debt with ML systems. This concept is true then and probably even more so now. The reality, as you can see on the right, is a slightly reorganized way of looking at that world, where the ML forms a critical and a central part of this AI solutions. But there are all these other areas that one needs to pay attention to really make a great AI system. And several of these areas are data dependent, they are infrastructure dependent, and they are process dependent. And these all need to come together in a very seamless way for us to make great conversation AI systems, and specifically conversational AI systems. Here's just another view of the same world that Google presented in their paper. This is more from my experience. My view is that you start with a use case definition. Once you know what the use case is, then you have to decide from a plethora of great advancements in research, which one of those advancements is relevant to your particular use case and your particular problem. Once that is decided, then you have to start digging into what is it that you want to model, the features that you want for modeling, the data that goes into the modeling, which falls under data ops. How are you going to, once the models are built, how are you going to deploy this, which falls under ML ops? And that's quite critical. And we'll talk a little bit more later in the presentation, why ML ops is important, especially with explainability and traceability. Once that is done, then you have decided your model, you have decided what data goes into it. Now you have to think about, from a production system, compute resource constraints, what role do they play? Obviously, you can't throw the biggest, baddest, meanest system, algorithm out there, which you may get great accuracies with, but it just doesn't scale. And from a costing standpoint for the business, it doesn't make sense for you to deploy such a system. So you have to consider compute resource constraints. So this is another way of looking at all the variabilities in defining an AI system. Fortunately, a lot of progress has been made in addressing a lot of this problem. For example, with ML ops, there are just a lot of tools out there from which you can choose today. You have very simple tools like ML Flow that allows you to uh, deploy models in production. There are several other tools for data ops. Several companies build their own data ops pipelines to achieve that. The data constraints are slowly being removed with the availability of data, and we'll talk a little bit about that. So, all in all, even though this looks very onerous with lots of variabilities that you have to worry about, there has been good progress made over the last few years, specifically, and in general over the last decade, which has made creating great AI applications feasible. This just goes into a little more details because obviously the devil is in the details. When we think about data, we need to consider the various sources from which the data is ingested into the system, which would require a data ingestion pipeline, data transformations, and several other aspects of data. For any good modeling, feature engineering plays a vital role, because as they say, garbage in, garbage out. So you better be careful what goes into your model, and features play a great role in that. Fortunately, technology is advancing at a rapid pace where feature engineering will be a thing of the past. The reason being, with the advancement of transformers and sequence to sequence models, and in general in deep learning, the need for feature engineering has gone down significantly over the past few years. And then there is model serving. And as I mentioned, there are lots of tools out there to help with model serving. You don't have to reinvent the wheel, you just have to hitch your ride with one of the ML ops pipelines that are out there. And then the application building itself. This is often ignored, and in a lot of cases, great machine learning algorithms fail to amaze customers just because of poor user experience design. So, one needs to pay attention to user experience while building AI applications. Now, we've talked a little bit about the generic applied AI world in the past couple of minutes. Let's see what a conversation looks like. Conversations between humans often look very simple from a human standpoint. However, when you just go under the hood a little bit, things can get very complex very fast. For example, on the left is a simple conversation between an agent and a customer, where the agent is soliciting the phone number from a customer. The customer starts off by reciting the first three numbers. Agent confirms those numbers, and the customer finds that the agent has heard the number incorrectly. So he goes ahead and corrects that. And notice how seamlessly the customer says, no, that's five. And the agent knows that the five is a replacement for the nine and not for the six or the three. So there's a lot of semantics that are happening there that go beyond just words. So in the end, a long 10 plus turn interaction, all we got out of that was a simple phone number, something that even a 2 year olds or 3 year olds can easily manage. So that's the complexity that conversations throw at us. And we are not even talking multimodal conversations. This is all with voice. Imagine, when we bring in multimodality, and you also have to deal with the visual cues that people give. Visual cues will come in handy, especially with emotion. There are gestures that you need to pay attention to. So this is all complexity that uh, conversations anatomy has. So even though conversations are as complex as I said, they truly are a treasure trove of information for enterprises. Enterprises can glean several things out of a conversation, and that's one of the reasons why conversational AI is such a hot topic today. And I would even venture to say it's booming business in the conversational AI world. The reason being the insights that you can glean out of these conversations. The simplest of them that we can easily understand is intents, which is primarily the intent of the conversation or the reason for the conversation. And then there is entities, which helps with either business logic or fulfillment. And then there are non-verbal cues or suprasegmental pieces of information, such as sentiment and emotion, which play a key role for a lot of businesses. And then there is engagement. That is not something that people track often in conversational AI systems, but we at Unifor find that to be a vital piece of information that is required to really guide a conversation or help agents do their jobs better. And then come a couple of other insights, such as promises and complaints. So when an agent makes a promise to the customer saying, I will return your call, or I will have my supervisor return your call, that is something that needs to be tracked by AI or could be tracked by AI and remind the contact center or the enterprise that a promise was made, and can you follow up on this, because it's been more than 24 hours since I detected a promise for this particular customer. Imagine the benefits of follow up of that nature to the end customer. You will eventually delight the customers because of the of this kind of engagement that was driven by the conversational insights. And in a lot of self-service use cases, surfacing knowledge at the right time is key to containment as well. For example, when I call into a bank and I ask for the current interest rates on home loans, it's not really, even though you could consider it as an intent, it really is a lookup from a knowledge base. Whatever is your current knowledge base, you look up the interest rates for the home loan and present it to the customer. No human involved, a simple two-turn conversation, and the customer goes home happy. So these are all the things that conversations hold for us, and mining that obviously is very key, and conversational AI plays a critical role there. So conversational AI obviously has been in existence for a while. Early on, it was primarily replacement for the traditional IVR systems where we punched in numbers to go through a simple flow to accomplish a basic task. Conversational AI helped reduce the mundaneness of that task to make it a little more natural, yet the flows were still very simple. Today, conversational AI systems are capable of handling flows that are very complex. They can handle soft landings when systems make mistakes or the customer provides incorrect information. Conversations don't reach a dead end. There are simple ways in which you can change the flow of the conversation to solicit the correct information so that the customer on the other end doesn't feel burdened by the fact that they're talking to a machine. Then the advancements in speech recognition have made dealing with intents and other aspects quite easy in the conversations. The future looks obviously even brighter, given the complexity of conversations that we can handle. Um, and this comes because of the advancements in ASR, because of the advancements in natural language processing, because of the advancements in the compute power that's available out there. There are a lot of aspects that I'll touch upon in a couple of slides. But the complexity of what conversational AI can handle in the very near future is uh, mind boggling. We go beyond simple self service systems or intelligent assistants to mining information and giving guidance to humans while the conversation is happening in real time. That's the future of conversational AI. What makes conversational AI challenging really is the multifacetedness of conversations. There is the aspect of domain, and what does that mean? And I'll give you a quick anecdote that we ran into quite recently. You may have heard about the release of large open source ASR model called Whisper. This was open sourced by OpenAI, and so we gave it a quick whirl. First off, open sourcing such massive ASR systems is amazing. It's great for exploratory analysis. It's great for pushing the envelope. Um, that particular system, Whisper, was trained on 600,000 plus hours of speech. Imagine that. We were struggling to train systems even with hundreds of hours of speech. This took that to the next level by changing the complexity by two orders of magnitude. Having said that, trying that system on a simple banking domain corpus shows how brittle the systems are. The error rates that we saw on the corpus that we tested on was probably in the 30% error rate, which is yes not usable for most insight mining systems. Then there is the complexity of language. We'll talk more detail in a bit. Then there is modality. So multimodal systems throw challenges. Then there is infrastructure constraints that we need to look at. So these are the facets that you have to look at before building a good, workable, efficient conversational AI system. Even though I sounded a bit pessimistic with all mentioning all these challenges, I truly believe we are entering the golden age of conversational AI. The reason being the technology is ready, the people are ready, then there is data that we can build great systems with. The technology is ready because of the advent of transformers, the advent of end-to-end neural approaches. Accessibility to the compute today is way beyond the imagination of a lot of us old timers thought would be available. And then the availability of pre-trained models that can be fine-tuned to a lot of applications and use cases, that's been a huge boon that will just propel the performance and the applicability of conversational AI forward. And then the people, there truly is an army of practitioners today that we couldn't imagine 10 years back. It was a pretty eclectic field a decade or 2 decades back, but today the number of people who can contribute significantly to building good conversational AI systems is really, really vast. And with that army of practitioners comes obviously possibilities that we couldn't have thought of early on. The availability of open source literature is also a boon that also used to be very limited to the academia or large corporations. Not anymore. Now you have these open sourced in archive, for example, is a great place for you to find open source literature. And also with the success of conversational AI systems and the bots that we use in our daily lives and the assistants that we use, the Alexas of the world, the business is truly a lucrative business, which means people are attracted to pursue this as a field of interest and hence become available to contribute to building great systems. And finally, data. There is a lot of open source data that's available to build conversational AI systems, both for speech recognition and for natural language processing. There's a great vendor pool out there that was really hard early on. During my research days, a couple of decades back, used to be primarily limited to Linguistic Data Consortium (LDC) and a couple of other vendors. Today, there are just so many vendors you can pick and choose from. Vendors that specialize in certain areas, vendors that have corpora that you can buy off the shelf, and so on and so forth. And there are tools for rapid development. That is another big change that I think will help make conversational AI really successful over the next few years. And finally, in terms of data, low resource is really history at this point. Even for languages that we thought were low resource languages even a couple of years back, thanks to governments around the world making this a priority, as well as academia and industry coming together, low resource languages are a thing of the past. There is sufficient data for most languages of interest in terms of business needs anyway. I'm a big fan of Dilbert. I think Dilbert comics can teach us profound things. In this case, just adding a little humor to the presentation. But seriously, though, I really feel like that second thing that Dilbert says, you don't want to go to war with the data you need. You have to go to war with the data you have. That is so true in our daily lives as practitioners of applied AI and applied conversational AI, to be specific. You can hope for great amounts of data with great quality, but that's not reality. You have to be scrappy, you have to be resourceful, and you have to be creative to get the data that you need to build great systems. That is the life in the day of any conversational AI specialist today. There are a lot of data strategies one can employ. First and foremost is, if you do get your hands on real data, first thing is cherish it. You sanitize it, because we do want to take privacy laws seriously, and then use it. Of course, from a source standpoint, there is open source data that has its benefits. You can jumpstart new research and new modeling very quickly with open source data, but often it's not completely relevant to your particular use case, and you don't know the inherent biases in these data sets. So we often look at curated data, which is more expensive and time consuming, but it is high quality data where you can build great models with. And then there is data from your customers in the deployments. Even though there can be vast amounts of data available there, they may be very domain specific. So the variety that you need to build generic conversational AI systems may not be there. So you pick and choose. You may want to mix and match these three sources of data to build the data set of choice for your particular use case. And then comes languages. We have already touched upon some of the complexity that languages throw. There isn't a conversational AI system out there that hasn't taken into account the impact the language coverage has in the planning that they do. You have to worry about low resources available for a given language. You have to worry about multilinguality in your particular use case. Today, for example, in Indian languages, code switching is a very common phenomenon. You rarely speak a monolingual form of speech. It is always mixed with English, and not just in urban India, but even in rural India. So systems need to deal with that duolinguality. Then there is accented speech. Yeah, and it's not just specific to large countries. Even in within states in India or within states in the US, for example, the accents are very varied, and sometimes to the point where you may want to think of them as a separate model to deal with certain accentual variations. And above all these things, there is, obviously the written form. Some languages, such as Japanese, are very complicated from a writing standpoint, because they have three forms of writing, and your systems need to be able to work with those forms of writing. So these are all the aspects you have to consider before charting out a plan for supporting several languages for your conversational AI systems. The choosing the model that is right, that's obviously most important from a science standpoint. I don't think we should shy away from simple models. There is nothing stopping us from the KISS principle, just keeping it simple, stupid. Um, in several cases for NLP specifically, we found that simple TF-IDF with embeddings and cosine similarity can lead to great systems with excellent accuracies. So we don't have to always go complex. On the other hand, there are certain topics and challenges where complex deep neural networks are what is required. So be prudent with what you choose of with your modeling. Data needs for models have to be considered. You can't just decide that you want to use a particular modeling mechanism without considering if there is sufficient data to support that choice of a model. You have to decide whether you want to do fine tuning starting with a pre-trained model, or do you want to build it ground up. Ground up has its advantages, but it has its disadvantages, especially with the amount of compute that you have to throw at this modeling. So there are a lot of these aspects. There is supervised learning, unsupervised learning. We could have another webinar just to talk about this, but my point is there are all this things that you need to consider for modeling. Be patient, be careful with the mechanism that you choose, so that there is a good balance of accuracies and productivity and efficiency of your system. In conversational AI, context is vital. This is something that is not often used, but I feel like the future of conversational AI depends on infusing this context into our systems. There is syntactic context, which is a known thing, where you can really break up a sentence into useful parts and separate it from the noise in the sentence. There is user specific context. If you knew that the user was from a particular geography, the information you surface and the conversation you have with them has a certain flow. Using historical information could be quite useful as context. Using domain information, I gave you the example of banking earlier. So knowing the domain helps craft conversational AI methodologies really well. And it also limits the data needs while getting the accuracies to really high levels. Joel mentioned in my introduction that I'm a big believer in tooling. Having great models is not sufficient, because often there is life for your models and your conversational AI system beyond beyond the deployment that you have made. Once it is deployed in the real world, um, you need business analysts to gain insights out of your system. You need your support team to be able to troubleshoot if the model is not behaving as expected. You need your user interface designers to iterate and adjust the dialogue's flow for better user experience. So you need tools for all this. So you have to pay attention to what is the purpose of the tool, what is the persona that is going to use the tool, and which phase of the development of the conversational AI system you have. There are a lot of trends that are happening in tooling. Just as a highlight, I think visualization in tooling is just amazing these days. So that's been a big boon for us. The low code, no code approach is great. Data centric AI with data programming, I'm a big believer in its future. It can really unleash tons and tons of data for us that wasn't possible previously without having a big investment into human capital. With data programming and weak supervision, you can get away with a minimal amount of human intervention for creating large corpora that can really bolster the performance of your models. A lot of companies we have worked with, specifically Galileo, which helps with data intelligence, as they call it, snorkel flow, rubrics, qbox. You should look some of these up. see what's out there in terms of tools that can help you while building your system, and after you built and unleashed it into the real world. Overall, I would like to end this short talk by saying that conversational AI truly is ready for takeoff. We have the tools to make it happen. We have the data that's available and the vendors that can make it available for us. We have the infrastructure and the compute taken care of, you know to a large extent. We have the models and the science that has improved by bounds, leaps and bounds over the past few years, that can make this really feasible. So I'm really optimistic with what conversational AI can bring us, especially from an applied standpoint, not necessarily just from research, because we have all these things handy today that was not feasible 5 years back. Um, with that, I end my talk here, and I would like to take any questions if anyone has.
Thank you so much, Dr. Ganapatharaju. We're grateful to have you here with us today to share your thoughts about conversational AI. So, right to the audience questions here then. The first one, it comes from Romuel Jester Menong Song. He wants to know, or she wants to know, do you think that conversational AI will replace human employees within customer service teams at some point in time? And when do you think this might happen?
Think conversational AI will not really replace, they'll replace a big chunk of them. But conversational AI really will shine by making them more efficient. That's where conversational AI really adds more value than replacing humans. Of course, for simple tasks where customers can self-serve themselves, conversational AI will play a role. But it's the uh, enhancements and the information that we can provide the agent in real time, that's where conversational AI will help. So overall, I guess the answer is no, they will not replace humans, in the near future. On the other hand, they'll make them really efficient, a lot more efficient than what they are today.
What are some of the challenges for designing chatbots?
Chatbot challenges primarily are with thinking about the the variety of ways in which customers will interact with a bot. So historical data with most chatbot companies would be all human conversations, because that's how the contact center worked. Now, trying to pare that down into a bot's flow is not really straightforward, because we really don't know what the reaction of the human to the bot would be. Would they really like a very guided flow, or would they want a very open flow? That kind of user research is important and can take a lot of time. That's one of the challenges. The other challenge is, after the bot is in the real world and people are using it, how do you really get the feedback into the system efficiently without having too much human effort? That's another big challenge for chatbots.
All right, we've got about a minute and 15 seconds left. Why don't you look on the right side of your screen there and pick the most thoughtful question you can find for us so we can award a prize.
I think I like this question on what's the single best lesson you learned in your years of experience in applied AI that helps you excel in resolving challenges in conversational AI. I really feel like the need for tooling that can um, help cater to the customers once the conversational AI is in production. That's where systems are made or broken. That's one of the big reasons. I'm a scientist at heart, so it was hard for me to believe that that was the case. I was a big proponent of models. Now, not so much. I think the models can still be simple, and if your tooling is not right, the uptick in usage of your conversational AI platform will not be that large.
All right. Thank you so much, Dr. Aravind. That was a great talk, and the answers to the questions were great too. Thank you for being with us today. You have a good rest of the day, and everybody else, stay tuned with us for the next session.
Thanks, everyone.